Perfect, perfect. So thank you for being here. I know it's a little bit late in the afternoon, and so I'll go through a little fast. If it gets boring at any point of time, wave at me so I can do something more exciting. Very quickly, this talk is going to focus on how to use, or what are the tools that you can easily use to use machine learning for identifying web malware, which you can run in a VM, and so on and so forth. The goal is that when you go away from this talk, you should be able to open up a browser, go to the internet, download the tools, and just get to work. That's the goal. There will not be like a hands-on presentation per se over here, but it's an introduction to the tools. What are we doing at Cloudflare? Why are we doing it? How you can do it for your organization, for your own personal self. So very quickly about me, I live in San Francisco, and I focus on understanding how web malware works. And we talk about JavaScript, PHP, Perl, Ruby, Python, anything that gets embedded on a website, on the hosting side, so on and so forth. I also focus on machine learning. That's also my background, where I try to see that without using signatures, understanding the behavior, how can we predict that this particular piece of code is going to do something bad? We have a couple of patents, and the way we started off is I had my company called Stop the Hacker, which it's a bad name in this context because we're all good hackers, but we got acquired by Cloudflare, and so I'm now at Cloudflare, and I do the same thing for their infrastructure and for their customers. Web malware detection is my area of expertise, and I primarily interface with hosting companies like GoDaddy, DreamHost, any of the larger hosters. We work with them to try and solve this problem. I'll spare you the slide. Very quickly, Stop the Hacker focuses on identifying web-based malware. If you give us a website, we will tell you on that website, a.html, on line number 34, here's an iframe, here's a piece of JavaScript, here's an advertisement that you're showing, and we can also clean it out for our customer automatically. And I'll go into how we do what we do and all that stuff. But that's the goal. Our main client base is primarily SMB customers, very few enterprises. So that's the perspective from which I'm going to be presenting today, that all the discussion that's going to be happening is about more or less SMB websites, small to medium business websites, not hardcore enterprise websites with 50,000 applications and such. Again, we also work with hosters a lot. So we have access to not just the front face of the website, but we also have access to what is on the hard disk of the hosting server itself. So we can see from both angles when we do any type of scans. Very quickly about Cloudflare. Cloudflare's main business is DDoS protection, CDN optimization. We do have a WAF that we provide to our customers. And on a daily basis, we see a pretty significant number, like 5 to 7% of internet traffic flows through us. So we have a very good idea about where something is happening, what is anomalous, what's going on, why is suddenly a website being hit, because a lot of customers use us and they put their multiple domains on us and so on and so forth. So a lot of traffic goes through our infrastructure. We contribute to open source projects, Nginx patches, we use Lua and Go, and you can go to our GitHub repository for Cloudflare and check out what we have. You can go to our blog too. Yesterday we released keyless SSL, which is a big thing for our customers and for people who are using. You no longer have to give us your private keys for us to make a secure SSL connection. It's completely keyless at this point of time. More information is on our blogs. So we do try to contribute a little bit to the open source movement. Very quickly, from our perspective, what we see is the fight against web malware is not succeeding. If you just look at the raw numbers, more than 10,000 new websites are getting hit with web malware every single day. And this is just on the Google Safe Browsing list. We're not even talking about any other of the blacklists, and these are the ones that we know about. There's a whole new world out there that we don't really know about. So if you just plot the graph of how many websites are getting infected every single day, it's literally scary, and it boggles the mind that why is this happening? Why are we not winning this thing? Enterprises and all these hosting companies, they are spending billions on antiviruses and other WAFs and whatnot, but it's not working. One of the problems that we face when we try to detect web-based malware is AVs cannot really handle polymorphic malware that well. They have come a long way from just doing signature detection. They have very good people on their staff, but malware keeps changing. If you look at hosting companies, what are they using? They're using ClamAV, any Linux-based AVG or anything like that on these servers to provide at least some base level of security for their clients. There are problems with this approach because these free services and so on and so forth, they are not updated as frequently as paid services. Moreover, the frequency of how many times you will run it on the hosting account, there's a very fine balance that you need to do where the customer needs to get a specific amount of CPU, specific amount of throughput, so on and so forth. You can't be running AV all day long on the hosting account. So it's practical problems that you run into. Pattern matching, as we know, it's trivial to change code structure. That's not a problem. Even if you look at simple JavaScript, simple PHP, C99 shells, or anything like that, people are still using tools like Malware, Yara, Perl, grep, awk. These are great tools built by the Unix community, but it's like trying to fit a square peg in a circular hole or something like that. Why are we using grep and awk to search for malware? That's not the point of grep and awk. They were built for something specific. Let's try to use it for something specific. As we all know, there's lots of various attack vectors that are on the that are used to attack websites. These are the main things that we see. Again, from an SMB website perspective, the way this is different from enterprises is, in most enterprises, you will not see ads being a vector for attack. You will not see themes as a vector for attack. You will not see plugins as a vector for attack. But in the SMB market, there are big issues with this. There are WordPress themes, Joomla themes, whatever you want. They are pre-populated with malware. Don't even need a vector. Just get the theme. It's pre-populated with malware. And people don't understand what they're doing. Somebody's just learned to code a little bit. They want to make a website quickly. They'll pull down a theme. Oh, looks good. Pump it in, and there we go. There's other kinds of attacks that are going on also. FTP-based credentials is like my personal peeve. I cannot get people off FTP. They will keep using FTP for some reason. Apache modules, SEO poisoning, there's all different types of problems that we have. And they're not going away. There are some high-level differences between when we talk about web-based malware and binaries that we talk about, what is dumped on the disk per se. For web-based malware, there is a high amount of churn. What I mean by that is the way the malware looks is different on every single website. So even if people are exploiting a specific WordPress or Joomla or some kind of vulnerability, it's not that you will see the same piece of malware looking the same dumped on all these websites. Why? Because these toolkits that they are using, which is trivial to get off the internet, they are smart enough. They're not that dumb. They're smart enough to understand that if I pump the same code everywhere, somebody can just write an awk statement and remove it from all these files. But I won't do that. I will try to modify the code structure a little bit. I will try to change the variable names, so on and so forth. And there are online websites that will do this for you. So it's very easy to do this. Some pieces of code are encoded. They're encrypted. PHP code can change. And they also link up to fast flux networks where the domain names keep changing. The IPs keep changing. So it's kind of like running after a rabbit, like where the hell should I, it's a whack-a-mole. Where do I kill it? So binaries, on the other hand, it's a little bit different because, again, from an SMB perspective, we don't see targeted attacks or binaries written targeted for an enterprise that I know you use a Solaris-based system. I know your developers use an Apple-based system, so let me write something that's specific for that OS. What we see is the generic shotgun, like P32s, let's spread them all around on Linux systems. So that's the basic difference, that we don't really see very interesting binary samples. One question that always comes up in web malware is, what is malware? Sorry, what is malware? Sometimes when we tell our customers, thousands of customers, we run scans every day, everything is automated, reports go out, some customers will write back, hey, you're pointing to this ad. Why is it malware? And we'll show them the entire trace saying, this is what the ad did, this is where the redirection goes, this is where it ends up, so on and so forth. It pops up a nice box. The customers will say, but I'm earning money. It might be malware, but I'm earning money. Is this really malware? So then you go into a discussion of, yes, you're earning money, but you should really remove it from your site. So it's a constant fight to convince people that, yes, please do something about it. Other things like we see PHP, ASP shells, all this entire array of different types of web-based malware that gets dumped on hosting accounts. This is not new, but they're still going strong. We still see C99 shells. I mean, can you believe it that we're living in 2014, we have WAFs, and we still see C99, C100 shells as it is being dumped onto hosting accounts. It's surprising. When we scan web hosting companies and we say, hey, web hosting company X, you have, let's say, 700,000 websites. We'll scan all of them for you. You will be surprised. 4% right off the bat have malware. And they're not even sophisticated malware. They're like C99 shells, R57s. It's like, dude, where are you living? So it's crazy. Some malware is smart. They try to do something smarter where they'll say, oh, you're coming to visit the website. Is it the first time that you're visiting me? Then I'll try to infect you. What user agent do you have? What kind of, let's say, what kind of a place are you coming from? GeoIP, the time of day. There are certain pieces of malware which are a little more sophisticated in that sense, to not to like do shotgun approaches and get caught. Blacklists, as we all know, are very outdated. And you might have read an article which we suspected in the past is a lot of people are actually using VirusTotal to fine-tune the malware that they are building. So you keep using it, and then when you don't see any detections, then you actually push it into the web malware payload and say, here's the piece of JavaScript. The JavaScript will now pull in whatever it needs doing. And we've just provided a nice interface to all these guys to test out all their binaries and find out what works. No wonder AVs have very poor catch rate, and especially for web-based malware. What are the roadblocks? Are the hosting companies bad guys? No, of course not. We've worked with a lot of hosting companies. They really want to solve this problem. But there are some practical issues over here. Some of the practical issues are the thin margins. If you remember, hosting account prices start from $20.99, $4.99, $1.99, free. How can you support a business model which is a race to zero, in a sense? They have very little money coming in per customer. The second thing is there's issues about data privacy. Is it a EU safe harbor thing? Is it a US safe harbor thing? Where is the data going out? Who has access to data? It's very difficult for the hosting company to actually go in and say, hey, you know what? There's malware on your account. We're just going to remove it. We're quarantining it. Good luck. People get very angry, even if it's pure malware. People get very angry, very pissed with if anybody touches their stuff. They have dynamic environments. They are getting DDoS day and night. We are taking some of the load off them, but there are other hosters who are not using CDNs and so on and so forth. So they are always under pressure. And for us, for example, at Cloudflare, we are a CDN, but how much of the world actually uses a CDN? Very few. I mean, we have millions of customers, but the total number of websites is much more. We only see a small portion of the internet going through us. So most of the people don't use a CDN. And moreover, malware is a big problem for us, but it's, again, from a management perspective, it's not a core business. It's an important thing to solve, but our core business is DDoS mitigation and CDNs. Again, that's some of the issues with people who are interested in solving the problems but can't really. Very quickly, just to provide an example, I'm sure everybody understands web malware, but just to provide an example, here is a classic piece of what you will see. Customers on our website can go and see if we say, hey, we found malware. They can drill down and see what is this malware, what does it look like, and we can show them that here's a little script and this is what it's doing. These are the variables, all that stuff. Here's another example. Again, these are not mind-blowing examples or something of that sort, but these are the typical things that we see and hosting companies see on a daily basis, where there might be a direct injection, somebody doing a document.write in there, and a little more fancy in a sense, you will have obfuscation of some sort where you will change the variable names. You will not have standard variable names and equal to signs and data structures everywhere, so on and so forth. Here's one example where you can see this on a regular basis too, that some websites get infected multiple times and there's multiple lines of the same PHP that they are referring to, and we have a running joke that the bad guys know the value of backups, so they infect it multiple times. If this doesn't work, that'll work. So more examples. These are, again, indirect injection where they are basically trying to use an iframe to pull in stuff and then lead you to another binary that will actually do something. There are also cases where websites don't just get infected by themselves. A lot of websites, if you think about it, a lot of SMBs, how do they actually make money? They will put ads on their sites. How will they put ads on their site? Either by putting a Google thingy saying, hey, or Yahoo, or some kind of ad network, or a lot of them who are somewhat more sophisticated will install something like an ad server, an OpenX server, which will pull in ads based on a ton of different things. People go after the ad servers too. Why? Because it's one point of failure where if I can compromise that, every single impression that you are making with your website is now compromised. I don't have to compromise 20 pages. I just go for one page itself. So there's somewhat interesting things like this. Another recent example you might have read of, the security community put out a lot of information about a specific kind of malware called dark leech. This is not new, but the reason I'm showing this is because it shows the evolution of stupid malware to slowly increasing in sophistication. This one, basically what it does is attaches itself as an Apache module, not just going into a file per se. And then what it tries to do is, based on the browser itself, it will decide, should I show you the malware or not? The beauty of being as an Apache module is anything that passes through your web server, I don't care whether you're website X or website Y, I can put it in your outgoing HTML and so on and so forth. Then what it also does is, when you connect with me, I will loop through the IPs that are connected by SSH to understand, are you a system admin who's trying to probe the website? If you are, because we're assuming SSH, you're not the normal guy who doesn't even know FTP, we will not show you the malware if your IP is on the SSH list. It keeps changing the iframes that are served out. Ultimately, the goal is to serve an exploit pack that will pump in a Java exploit, an old IE exploit, or things like that. Final result is it will connect to the Zeus network. It wants to steal your credit card information, pass it through a ZBot network. That's the ultimate goal. So all this fancy stuff, that's the way we think about it, is web-based malware is not the actual problem. It's the delivery mechanism for the pill. So if I'm trying to infect you, that's the bus which is carrying the bad stuff in it. And what we are trying to do is go one step upstream and say, let's catch the bus, let's stop the bad delivery mechanism. We have people working on binaries, the entire security community. Let's also try to stop this thing from getting to your browser in the first place itself. Some of the easy things that we can do, how to make it a bit harder. There are companies out there, hosting companies, who are releasing custom CMS packages like DreamPress from DreamHost. I just mentioned this as an example. There's many other hosting companies that are releasing customized packages. Why is this a good idea for most people? Because they don't forget to update, they don't understand what themes they're putting in, what plugins they're putting in. So somebody who understands it more than them packages stuff nicely. It's a one-button click installer. And we encourage people to, like, hey, if you have a WordPress website, go get one of these prepackaged things because somebody has thought about security over there, versus you downloading something, writing tar-xvzf, and then forgetting something else. Like, let somebody who knows a little bit more do it for you. We also encourage people to get at least some kind of a free WAF. For example, Cloudflare has a free WAF. There's a free level of service anybody can sign up for. At least get that, or somebody else. Doesn't have to be Cloudflare. Just get some free WAF. Try and do some simple things. The biggest thing that we have struggled with, though, is educating end clients. And we have worked with groups such as Stop Badware, which is, if you guys go look it up, it's a very vibrant group in a sense. And it is supported by Google and by PayPal and by a lot of other important companies. And what happens is, if your website does get infected and it is detected by Google, you will get an email from Google saying, hey, we've detected malware on your site, you need to do something about it, and it will contain a link to stopbadware.org. And that's where we also participate to educate people that this is what you should be doing, this is what you should not be doing, so on and so forth. But that's something that we have struggled with, in a sense that there's not enough knowledge in the community. We've also tried to work with hosters to say that whenever anybody signs up for a domain, whenever anybody signs up for a hosting account, you have to send them this email or send them this link to a webinar or something of that sort. But that's not always easy to do because people try to make it easy to sign up, and you cannot have multiple things in the sign-up process and so on and so forth. Some of the challenges. From our customer base, what we see is not a surprise, but WordPress is going really strong, Joomla, and then front page is still there, it's alive. Dreamweaver, Perl, ASP, and all that stuff. Now, WordPress by itself, that's not the scary part. The problem is, the scary part is that WordPress is insanely easy to set up, and then people forget. The developer leaves, the guy who owns the website doesn't care, so on and so forth. So ultimately what happens is something like this. Our customers, when we look at them, like we're tearing our hair out, like what's going on over here? And please, we beg you to update, but it does not happen. Here's the funny part. One of our customers told us that, hey, when you detect malware on my site, you just go in and remove it. Yeah, we do. Okay, so why should I update? I'm like, and I saw his reports from the last like 10 days. Every day there's an infection, there's a report saying we removed it. Infection, removed it. Infection, removed it. It's like, oh my God, why did we even release this feature? It's like, people will just not upgrade. So whatever we've seen till now is web malware, why is web malware bad, and so on and so forth. If we want to catch web malware, we also need to build a collection system for web malware. How are we going to get samples for web malware? What we decided is we are going to build our own honeypot. Why? There are other nice open source honeypots and honeynets that are out there. We felt that for our needs, we are going to build our own and ultimately open source it for everybody else. The reason we are doing this is because we want to have a honeypot that scales to 100,000, 500,000 instances and just keeps on running in a particular data center. We want really large numbers. When you go to really large numbers like 100,000 to 1 million honeypot instances, small things become challenging. Like things that you would not think that, why is this a problem? It becomes a problem. What we have started to do is we have bare metal servers on which we have a Debian-based OS. We've launched Docker instances on top of that. For people who don't know, Docker is a lightweight way of making containers where things can, it's like a virtual machine, but the difference between a virtual machine and Docker in the simplistic ways, every virtual machine has its set of libraries and everything, and it's heavyweight. Docker says, hey, I can reuse these libraries together, so I don't need the same amount of hardware to have 5 different instances. Very 10,000 feet kind of description. But what we do is we launch up different types of websites with different versions of WordPress, Joomla, Django, you name it, we can do it. And then ultimately what we do is sit there, come and attack us in a sense. This is not yet launched officially from Cloudflare. We're still working on it. But we have prototypes and everything. And ultimately this feeds into our real-time blacklist, which is fed into our WAF. And ultimately we are also going to launch a public API at one point of time that everybody can tap into. So why is this better? We can reach a lot of scale by using something like Docker, LXC kind of a thing, because it reduces the amount of hardware we need. Therefore, we can invest more in more hardware and really have 500,000 instances of honeypots running on our entire cluster itself. We can bring up any flavor of CMS, nearly any flavor of CMS that we want. We have a watchdog running in the background like a tripwire. What files did you drop in, and so on and so forth. Any file that you drop in, we ship it off immediately internally to a cuckoo-based virtual machine analysis system. And that basically shows us, did you try to modify the registry entries? Did you try to do a pop-up? We'll click on the button. What did you do then? We'll launch the browser. What did you do then? So on and so forth. So we have kind of like the ground truth in a sense of saying, this is what your binary did. Therefore, we are marking it as bad. Because ultimately, when we launch this at scale, people will ask, Why are you marking this particular thing as bad? And we need to have a very conclusive, concrete answer to say, we mark this as bad on your site because XYZ. And we can also show like screenshots and all that stuff for all our clients. Ultimately, the goal is that we are going to spawn any version of CMS that I say. We're going to monitor for WAF events. So how is this actually going to work in a sense where you can come to any particular website that we are supporting, and if we find that you are trying to attack that website either by a WAF event being fired up or anything of that sort, we are going to start putting you into our fake internet in a sense. The website looks exactly like the normal website. It'll feel internally, it'll feel exactly like that specific website, but what we'll do is we'll switch out WordPress 4 that you're running with 3.4.1 and see what you do. Are you going to probe more? If you're going to probe more, we'll see, okay. So it's like a step-by-step trying to understand what are you actually trying to do. The reason we are trying to do this is because our goal is to go to near real-time classification of good or bad access. We will never get to real-time. Real-time is very loosely used. We will never get to real-time classification within like 1 millisecond of you doing something, but it's trying to get to as close as possible. So how do we actually launch up this project called Tarpit? What we do is we have, and all this code and everything is going to be available soon. We basically use Vagrant, and then we use Docker to bring up all these containers. Each container has pre-created images, so we can say WordPress 3.4.1, version XYZ, release XYZ, whatever it is. And then what we do is, let's say it's, for the sake of argument, it's WordPress. We use Mechanize and so on and so forth to go to our cache and say, abcd.com is in our cache. What are the pages in abcd.com? We will bring that content, populate that WordPress instance, and show it to you. Ultimately, the goal is to mimic the main website and have the watchdog process running on the file system, seeing what are you dropping, what are you doing, because the WAF is already observing what are you throwing at the website. So we're observing the traffic, we're observing the file system too. So just a few, and I apologize, I couldn't do a real demo for many reasons, but just a simple screenshot saying that, let's say there are two instances that we're going to show the website. The Tarpit is not started, there's nothing in the browser. Tarpit is started, Borat is happy. And this, whatever content is over there, welcome to 123, welcome to abcd.com, this can be populated whenever we bring up the container from the website that we have chosen. We can just say with a hash ID, here's the hash for the website, go get the content from there, populate it dynamically. So we can do this for any of our customers. And a quick example of the kind of emails. We chose to send ourselves emails, but it also has an entire backend that shows what binaries have been put in and all that. You can get emails saying this particular install.php was dumped onto the hard disk, which IPs were involved, so on and so forth. And so just yeah, not major stuff going on, but the Cuckoo-based sandbox that we have, it can also show what pop-ups happened, what was the stack trace, what registry entries were modified. So again, we're going one step further to saying we want to be as definitive as possible when we tell you that something is bad. But it's not all gravy. There are many challenges over here. The first one being that we have to rotate the IPs ultimately that we use for these things, because we are a big target. We have like a big target painted on our faces for DDoS itself. We had an NTP reflection attack targeted at us and our customers, 500 gigabytes per second, 400 gigabytes per second. It's crazy. It is getting more and more crazy by the day, and people are going after us for a multitude of reasons. It's political, I don't like you, it's a business thing, and we have to absorb those attacks because we are the front face for most of our customers who are behind our infrastructure. There are people constantly trying to hack us for who knows what reasons, but anyways, we have to keep up with new variants. Web malware keeps changing, and malware is getting very smart. I mean, it's not trivial in a sense to identify if you're running in a VM or not. It's not that hard. You can get around it. There's well-established articles for doing that. So we have to kind of keep ahead of the curve, and it's not that easy. There are some specific malware that targets mobile devices. We don't know whether we want to go after those at this point of time or even how to do that in a good way, but that is something that we want to explore. So here's one interesting twist that we put on our target. When you try to attack one of our customers, we know you're bad, but why just cut the connection there? Why not see what you really want? So what we're going to do is, when you try to push in a shell, we're going to generate in real time juicy information. Here's a directory of credit card numbers. What do you want to do? Then here's a directory of other database. Here's a live database, MySQL database. What do you want to do? So what we want to do is see exactly for a specific organization, what are you trying to get to? Do you want the database dump? Do you want the credit cards? Maybe you're not interested in either one of them. You want something else. So it's a work in progress because we even don't know what you will actually be interested in, and we are doing probabilistic behavior analysis to say what should we show you. So that's an interesting thing, but we've just started on it. We want to understand what techniques are you using, what targets are you going after, and what's your ultimate goal. So we'll talk about machine learning, not about AI. AI is misused everywhere. We don't have bots running around with guns and all that stuff. So AI is like, we're over it. So why should we use machine learning? We've seen web malware is a problem. We've seen how to capture samples of web malware. How are we going to classify them as good or bad? We need an initial data set to seed. For binaries and such, it's not that easy to get data. There are resources out there, offensive computing and so on and so forth, and there's some organizations, AV companies that have pooled together resources where you can subscribe and get malware samples. But again, it's not trivial. What we want to do is also analyze what is important. We want to reduce the noise. Whenever you use machine learning, any data that you get, no data is perfect. Every data has missing features, every data has noise. It's very hard to identify what to strip off from the data before you try to actually analyze it. Another important thing is most people think, how do I say that this is a phone? Well, one way to say that it's rectangular and it does some radio stuff. Okay. Well, then the next thing is I'll add one more feature and say the front is made from glass. All right. So you keep on adding these features till what you try to do is say this is a phone, and there's 100 different features which say this is a phone. But the problem being, if you keep adding features like this and you want to do high accuracy based prediction, you need data that grows exponentially with the number of features that you're trying to analyze. And that can get out of hand very quickly. You don't have that much data. We luckily can see a lot of 5 to 7% of internet traffic. We generate about like 1 gigabytes per second of logs. So we have traffic, but we cannot even capture everything. We have to throw away a lot of logs. Like, how much are you going to store? What are you going to store? Is this important? Is this not important? So it's a challenge. We'll see that you will need to do PCA type experiments and use some basic rules of thumb. When you go away and you play with the libraries that we show you, straight off, instead of exploring the entire space, I'll save you some time. Go and look at algorithms that deal with forests and trees, LAD trees, random forests, anything like that. Don't look at other things over there. They will not lead to very good detection and classification precision. Not that because I'm extra smart or something, but we've spent the last 6 years doing this. That's the only reason. So if you are interested in this, feel free to look up these particular libraries. They are in pure Python. They are very easy to use. Very, very easy to use. There's a big base behind these guys who are publishing this project. They are very helpful. There are lots of examples. There's code that you can just plug and play kind of a thing. Scikit-Py, Scilern is one of the projects. PyBrain is another project. Weka is another project, though using Weka in a commercial sense can be a little bit hairy because they have some licensing issues. So when you go away and you look at Scikit or PyBrain, what should you be? Why should you be looking at them? Because the first one is PyBrain. PyBrain is an artificial neural network simulation system. What it does is it tries to use neural network-based policies to give you a classifier, any kind of clustering mechanism that you want to use. It's actually very powerful. What we use it for at Cloudflare is to basically say, given a set of data we have no idea about, tell me what clusters are there. Because unless you form some kind of an idea in your head that there are 4 clusters, there's 5 clusters of malware, it's very hard to go and say, I'm just going to classify everything under the sun. You have no idea about the data. How are you going to move to the next step of classification? So the first step is doing some kind of clustering, understanding what data you have. PyBrain is great for that. It is very powerful. And there's code samples, everything on their particular website. The next one is scikit-py or Weka. I would prefer scikit-py. You can use Weka too, whichever one you prefer. This is used for classification. Once we have an idea of the type of data we have, we use scikit-py to say, given this sample, given this feature set, which bucket does it fall into? Good, bad, or unknown? Anything of that sort. This is what scikit-py is used for by us. And it is also very powerful. It has multi-class, multi-label properties. It can handle that kind of data. You will need to do constant retraining. The way machine learning works is we've been bombarded with movies and everything which says, AI, once you give it that information, hands off. It's going to learn by itself. Well, let me tell you, there's nothing that learns by itself. There's no system that just keeps on learning and keeps understanding and so on and so forth. The human in the mix has to go in and make sure that you keep retraining with your new samples. You understand that the system that you have built, it understands what these new samples do. You get their features and populate your samples with them, so on and so forth. So there is a manual effort to this. It cannot just be pure code. There has to be somebody with some kind of domain knowledge that goes and does this on a regular basis. It can be 1 week, it can be every day, it can be every month if you use it like that. But it cannot be that it's a hands-off system, just to set expectations. Why use the system? What we have found from personal experience is any kind of fuzzed iframes, they are caught easily. Any kind of encoded PHP, JavaScript, anything of that is caught easily. And the reason we are doing that is because we want to identify the bus, the delivery mechanism. That's why we're doing all this thing. It also catches ad misbehavior. So if you have an ad which has some kind of malware, does redirections, try to drop in an Adobe vulnerability, exploit an Adobe vulnerability, it catches it before the binary can actually be transferred to your computer by looking at the number of redirections, how are you redirecting, who are you going and talking to. These are all models that we've built out. And you can too. It's not very hard. It does catch some binaries missed by AB. So just to make sure, this model, these policies are not going to give you substantial difference when it comes to targeted binaries that are going to infect, let's say, Stuxnet kind of a thing. It is not built for that. This is a good way to identify web-based malware. Problem with machine learning is everything is domain specific. What applies to one domain cannot just be picked up and put into another context and expected that it should work. It's doing the same thing, classification. Things change. The good news is you can tune it infinitely as much as you want. And you can get good precision and recall and accuracy with these kind of toolkits. And it's very easy to get started on this thing. How do we do it? We basically have a crawler that will go out, gather some pages from our cache or from the live website. We will pump it into a reputation-based module. Again, each one of these modules has its own machine learning logic. The reputation-based module will look at what's your IP, what's the ACE number, who's your host, what's the geographical location, etc. All these features, pump them through a series of algorithms, and they ultimately say good or bad or unknown. Moving on to the AV. We know that AVs don't work. We still have them for some reason. Moving on. Static analysis. Tell me about it. Static analysis. Here's the interesting part. This is where we've spent a lot of effort on by saying, simple example. Write me a piece of JavaScript. I'm going to analyze your piece of JavaScript and say, does this look good or bad? How? We've analyzed thousands and thousands and thousands of pieces of JavaScript from different developers of different levels. We know that when you write a piece of JavaScript, you write in a particular way. Suddenly, when we see a piece of malware, it's doing something very different. Why? That's the goal of trying to classify and say, this does not match any paradigms. Is this perfect? No, of course not. There are false positives, of course. So, but that's one way where we do static analysis as an example to say, what kind of data structures are you using? How many times is that data structure being referenced in the code? How many times do we think it's changing? What are your variable names like? How many variables names do you have? Etc., 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 features, so on and so forth. Then we try to do a dynamic analysis of using Rhino.js and running in a VM, trying to see what you did. If you actually try to pull in a piece of code, we feed it back into the system again. So JavaScript fetches more JavaScript. That JavaScript goes into that entire thing again. Fetches more JavaScript, goes into that thing again. Of course, we're not going to do this for infinite number of times. So you can defeat us if you have more than 256 times redirections. So, but anyways, we get all that information, we aggregate it, and then that's the pain of the thing. You have to retrain. All the new samples that you get, you have to retrain. Otherwise, it will not do well. Again, not much stuff on this. We are basically trying to catch the iframe and the JavaScript and other HTML elements and web-based elements before the actual attack payload. Some things to watch out for is you will come across this. If you try to play with these toolkits, initially you might be very excited to add more features to something and say, oh, wow, 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 accuracy increased from 90% to 92. Let me add one more feature, 93, 94, 95. But then it dropped to 89. What happened over there? There's a classic problem called overfitting. Most of you might know it, but very easy to explain in a sense where, think about if you have, in a space, there are 5 different points, and you want to say whether they are in a sphere or not. Some are outside, some are inside. If you increase the number of features, it's basically defined by a polynomial like x to the power of n plus some constant x to the power of n minus 1 plus da 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 da, all that stuff. As the n goes up, the power n goes up, this does not remain a sphere. It becomes like an ice crystal with spikes coming out. And at the end of each spike is your data point, which you are using to create this system. Problem is, in a real world, when you have a new sample that comes in, it'll hang somewhere over there, and the spikes are everywhere else. So you'll misclassify most real-world samples. So you cannot just be increasing the degree of the polynomial and saying, wow, I'm getting like 94, 95, 95, bam. When the test actually happens, nothing really works. So that's one thing that is a problem that everybody has to deal with. So don't get disheartened. Everybody has to deal with that problem. I mentioned about exponential data. One of the problems that we have faced in the past is when you build a machine learning-based system, you need the ground truth. You need to train the system to say, here are 10 samples. This is good, this is bad. When it's 10 samples, hey, it's easy. You can spend a day max. It's all good. When it's 10 million samples, who's going to look at it? Even if the hosters that we work with, they are telling us, here's the PHP shell, here's the 1,000 PHP shells that we found in the last month. Do we trust that all of them are bad? Do we trust that it's 100% accurate? Who knows? So it's another problem that to get accurate training data is not that easy. What I would recommend is if you do try to do something like this, please team up with somebody. It gets challenging, and you need some motivation from the other guy or girl. You should team up with somebody and sign up for some kind of a group which can give you some samples. StopBadware is a good area. Offensive Computing, any other website that you can find where you can get some samples. Without samples, life can be very tough. Some of the challenges for us when we develop Tarpid and all these things are new CMS versions. Every 3 months, 4 months, 5 months, CMS versions are coming up. We need to keep up with it. Effort has to be expended into making sure all those we have Docker images for every single one of those. We need a lot of CPU. When you do these kind of number crunching things, we need a lot of CPU. We need to have racks of servers in Oregon that are crunching numbers. It's expensive. And there's only a point till which you can offer this for free, because you just need a ton of CPU. Measuring accuracy at scale sounds simple, but it's actually very tough. Like just even getting the data of like 100,000 scans in a minute and saying which one was good, is there a false positive or not, it becomes very challenging. We have thought about using somewhat FPGAs, but have not really gone there. But that's one way that we think that maybe we can do something. Alrighty, speeding up now, as if I haven't been talking fast. Alrighty, PyBrain, scikit-py, please look these up. They are very useful, easy to use. Contact me if you have any questions. I will try my best to help you. Ultimately, this is a very quick, you can probably tell I like Borat, but this is the kind of like the workflow of what we have. There's no major issues over there. You can make virtual machine detection harder. There are articles about it on the internet. You can look at it, cuckoo-based, how to harden cuckoo and make sure that the malware cannot realize it's running in a virtual machine. It's not perfect. It's a start. We are going to, at one point of time, open source code for this. The code is not stable enough at this point of time. We don't want to release some whatever it is. So we want to make sure it's really well tested. Ultimately, what we also want to do is focus on malware that helps in DDoS, because that hurts our core business, and focus on machine learning for traffic anomalies. That graph is basically, we've marked out clusters using eigenvectors and eigenvalues to say, given a network, which nodes in a network are actually responsible for sending bad traffic. And there are nice clustering mechanisms. There's well-established theory about this. There's nice clustering mechanisms by which you can quickly identify groups of bad nodes and try to segregate them easily. So that's, again, something that we are trying to do. And the last thing is we want to do this inline machine learning at line speed for WAFs. Extremely challenging, but that's our goal. Anyways, that's all, folks. If there are any questions, please go ahead. No questions can be good or bad. All righty. I'll go with good. Oh. Stopbadware.org. Stopbadware.org. Yes, there are. I can add them in the slide and share them. I can provide a list of different. Thank you.